carbon dioxide is one of the gases that goes from the atmosphere and gets incorporated into seawater. On this graph, you see the oceans have 39,000 times 10 to the ninth tons of carbon dioxide dissolved in the ocean. Carbon dioxide, along with a couple other gases, water vapor and methane, and a few others, are greenhouse gases. Greenhouse gases accumulate in our atmosphere and do not allow for long wave radiation to get dispersed back into space. It basically traps heat, so that heat is trapped down by the earth. The main evidence for that has been, let me turn off my head, the Keeling curve. This is a curve that is a data set that was started in the 50s by Dr. Keeling, and he was in Mauna Loa in Hawaii, and started collecting data on the parts per million and concentration of carbon dioxide in the atmosphere. That data set is ongoing. You can see on this graph it goes to 2000, but it continues today. Keeling died in 2004, 2005, and his son took over the collection of that data in Hawaii on Mauna Loa. So the zigzag pattern of the graph is just showing that there is uptake of carbon dioxide from plants. So there's a seasonal variation in the carbon dioxide, but overall the trend is a big steady increase in carbon dioxide in our atmosphere. Okay, another part of the carbon dioxide story is the CCD. We've talked about it when we were discussing carbonaceous oozes. The carbonate organisms have, their hard parts are made out of CaCO3. Once they get to a certain depth, around 450, 440, 430 meters or kilometers, so 4,500 meters, then the shells, the hard parts, dissolve. That CaCO3 dissolves. At this depth, the water is cold, and the pressure is high enough that it holds more of that carbon dioxide. So there's a lot of carbon dioxide in our deep sea, and part of that story is the dissolution of those shells at depth.